Okay, hello everyone. I welcome to all in our lecture series on laser physics. In this lecture series, we are discussing these topics which are most essential for B.sc, B.Tech, M.sc, M.Tech and various entrance examinations. In our previous lectures, we discussed these topics. Up to this much we have been discussed. Last class we discussed the rate equation for three-level laser system. In this class, we are going to discuss rate equation for of four-level laser system. Okay, so let us start. These topics already we have been discussed in our previous classes. Okay, we discussed uh, Einstein's A and B coefficients and their physical significance and relation between them. Last class we discussed a rate equation of three-level laser system. In detail with note we discussed. Here in this class we are going to discuss the rate equation of four-level laser system. So I suggest to all of you that before you have to watch this video, you go through the rate equation of three-level laser system and Einstein's coefficient, Einstein's A and B coefficient. Okay, then you can understand this video easily. Okay, now we are going to start this topic. In this topic, we are going to discuss what will be the condition for laser action in case of your four-level laser system. For that, we consider a four-level system. This is the level 1, ground state you can say, level 2, energy level 2, energy level 3 and energy level 4. Same thing it has been written. E4 is your excited state. Here E3 is the metastable state which is nearer to the E4. E3 is closer to the E4. E2 is another intermediate state and E1 is your ground state. And here N1, N2, N3, N4 represents the number of atoms or molecules per unit volume in level 1, 2, 3, 4 respectively. Here I written. Or you can say concentration of atoms or molecules in these levels. Here, laser action is to be found in between E3 and E2 because E3 we consider as metastable state and E2 is the lower state as compared with E3. So in between E3 and E2 we can found laser action. Here B14, B23 represents the coefficient of stimulated absorption from level 1 to 4 and 2 to 3 respectively. So if I am going to consider this is the ground state and atoms are there, so we are going to provide the pumping energy. So atoms will be excited to the higher excited state or it will be excited. So here if suppose atoms will be here with uh, pumping energy, they may can excite up to this level 2 to 3. So for that we considered B14 and B23 the coefficient of stimulated absorption. B14, B32, 14 means from this level to this level. Stimulated emission 32, B32, 32 means from this level. Energy level 3 to energy level 3, stimulated emission happens. B32 represents the coefficient of stimulated emission. See this, what is the physical significance of B14, B23, B41, B32, or you can say stimulated absorption, coefficient of stimulated absorption and stimulated emission we discussed in our previous classes. Only for that I suggest you to go through those videos. Okay, so this represents, these two terms represents the coefficient of stimulated emission from level 4 to 1 and 3 to 2 respectively. Now here T41, T43, T32, T21 represents the coefficient of spontaneous emission or you can say probability of spontaneous emission. See here coefficient of stimulated emission we can say, or we can say probability of stimulated emission. This coefficient also can be written as probability of stimulated emission. Here also probability of stimulated absorption. So here T41, T43, T32, T21 represents the coefficient of spontaneous emission or probability of spontaneous emission from 4 to 1, 4 to 3, 3 to 2 and 2 to 1 level respectively. Here T represents both radiative transition and non-radiative transition. Radiative transition represented by A, non-radiative transition S. So a transition happens and contains both radiative and non-radiative transition, then it will be represented by T. If the transition happens and it contains only radiative transition, then it will be represented by A. Instead of T, it will be represented by A. Likewise, if non-radiative transition happens only, so instead of T, it will be represented by S. These things also we discussed in our previous classes. N1, N2, N3 and N4 are the concentrations or number of atoms, whatever I discussed. So total number of atoms in this system is equal to sum of all the atoms or molecules per unit volume in level 1, 2, 3 and 4. So here N, total number of molecules or atoms, is equal to N1 plus N2 plus N3 plus N4. So what we have to find out in this topic, or what is our objective here? Our objective is to find out the minimum condition for laser action or population inversion between 3 to 2, because in between 3 to 2 level we are getting the laser action. So what will be the minimum condition or population that we are going to calculate, or we are going to think at that time the laser action or laser oscillation is going to happen. Okay, for that we have to consider the rate equations of different energy levels. Here we consider rate equation of level 2. Level 2 means this one, level 2. So for this level 2, what are the transitions linked here? We can say this is one transition from E3 to E2. This is another transition E3 to E2. This is another transition happens from E2 to E3. And this is another transition happens from E2 to E1. So here you can see, due to this transition, this transition and this transition, concentration of N2 is going to decrease. So that the rate equation of energy level 2, for the rate equation for energy level 2, if I am going to write these two terms, this one and this one, will be negative, because due to these two transition N2 decreases, because N2 moving from this level to upper level by this transition, and atoms or molecules transit to ground state by this transition. Hence N2 will decrease by these two transitions. However, N2 increases due to these two transitions. Okay, so due to these two transitions, as N2 increases, these two transitions will be considered as positive, but these two transitions will be considered as negative. Okay, here you can see rate of change of N2 is equal to T32 into N2. T32 means here T32 into N2, that means this transition. This is your so-called spontaneous emission, due to spontaneous emission. So rate of spontaneous emission from E3 to E2 is nothing but your T32 into N2. Likewise, rate of stimulated emission from E3 to E2 is your this one, B32 N3 U mu. Okay, now if I'm going to consider this transition, this is your stimulated absorption, due to which N2 will decrease, so it will be written as minus B32 B23 N2 U mu. Again, this transition, for this transition the rate equation will be T21 N2 minus T21 N2. Right. Now we are going to move further. Same thing I have been written over here. Then I am going to substitute something in this equation, and then we are going to go for the simplification. So here dN2 by dt, same thing I have been written. Okay, same equation. Here we know E3 is the metastable state. Okay, E3 to E2, will be always radiative transition, because metastable state, this is your metastable state and this is the lower state. So in between these two states we are going to get the laser action. So whatever the transition will happen between E3 to E2, it will always radiative transition, right? Now E2 to E1, it is always fast and non-radiative transition. So from here E2 to E1 transition always a non-radiative spontaneous transition, right? So here, because E2 is very close to E1, so the transition will be non-radiative. And as we know, for the non-degenerate case, B23 equal to B32. Again, we consider B23 U mu equal to W1, which represents the pumping rate. So these things we are going to consider for this equation. Now this equation will be written as dN2 by dt is equal to, here this is the radiative transition, so T32 will be written as A32 N3. Here B32 into U mu is considered as W1 pumping rate, so W1 N3 W1 N3. Here B32 is nothing but B23, so B23 into U mu also can be written as W1, and N2 is there, N2 has been written over here. And T21, 21 means transition from here to here, is non-radiative, so instead of T we have to write S, so S21 N2. Okay, now consider steady state. At the steady state or equilibrium state, N2 value is a constant, so rate of change of N2 will be how much? Will be 0. So that implies this value will be equal to 0. So take these two terms this side, so it will be positive W1 N2 S21 plus S21 N2, and these two terms are here. Okay, take common from N3, from these two terms we can get A32 plus W1 N3 is equal to, here N2 taken common, so we can found W1 plus S21 N2. Now N3, here cross multiplication, N3 taken this side, N3 by N2, and this term taken this side, so it will be W1 plus S21 by A32 plus W1. Let us, this is your equation number 1. Now just subtract 1 from LHS and RHS. So what we can get? N3 by N2 minus 1, here same term minus 1. Now the left hand side will be N3 minus N2 by N2, and here right hand side will be W1 plus S21 minus this term by the same term A32 plus W1, right? Now just to simplify, here you can see W1 plus, here W1 will be minus, got cancel, so other two terms are this one. These are the other two terms written as such, S21 minus A32 by A32 plus W1. Let this is your equation number 2. Now consider equation number 1, this one. Here in this step we just subtracted 1, and here we just added 1. So considering equation number 1 and adding 1 in LHS with LHS and RHS, what we can found? Here N3 plus N2 by 2, and this is the simple addition, right? Now N3 plus N2 by 2, and this one same thing I have been written. Okay, same thing I have been written. Let this is your equation number 3. This is considered as equation number 3, right? Same thing I have been written over here. Okay, so you no need to write the same equation 2 times. Here I written because it will help me that I should not be go back to represent the slides. Okay, so here, so this is your equation number 3. Now dividing equation number 3 by 2, that means 2 by 3. Here this is your equation number 2. 2 divided by this equation. Here N2 got cancelled. Left hand side we can found N3 minus N2 by N3 plus N2 written here. Okay, and here this one, here you can see this denominator got cancelled, and we can found S21 minus A32 by this one, W1 plus S21 plus A32 plus W1. Same thing I have been written over here. Okay, now for laser action, the population inversion should be positive. Here most important, carefully you just watch. The left hand side represents what? What is the physical significance of left hand side? Left hand side tells that difference the number of atom concentration of atoms or molecules between these two states with respect to total number of atoms in 3 and 2 states. Okay, so here I am going to consider one example. Suppose this is one example. Uh, Suppose this is your N3 and N2. Total number of atom we are considering 7. Okay, one situation here 1 2 3 4 1 2 3. So here if I am going to consider N3 minus N2, N3 N3 minus N2 by N3 plus N2, we can get what? 3 minus 4 by 7. That means this value is negative. Another situation we are going to just consider. Suppose 4 atoms in N3 and 5 atoms in N3 and 2 atoms in your E2, E3 and 2 atoms in E2 level. So what will be the N3 minus N2 by N3 plus N2? It will be 5 minus 2, 3 by 7. This is positive value. Positive. So here, if this value, that means the ratio between difference of concentration by total concentration, if positive, then we can say it is the situation of a population inversion. That means population inversion achieved. Okay, so if this term is positive, we can say we got the population inversion, because laser action we can get or laser oscillation we can get in between E3 and E2. So population inversion should be achieved in between these two levels. So here this term represents the population inversion. If it is positive, then we can say yes, population inversion achieved. That means large number of atoms in your E3 level as compared with E2 level. So this is the situation. Here large number of atoms are there and here less number of atoms in E2. This is the situation, is called as your population inversion. How it will be achieved? It will be achieved if this term N3 minus N2 will be positive. So N3 minus N2 will be positive. How it will be possible? If this term S21 minus A32 will be positive. So S21 minus A32 will be positive at that time when S21 is greater than equal to A32. So here I written greater than that of A32. Many books they have been written greater than equal to. So you can write greater than equal to itself, no problem. So here if S21 greater than that of the A32, then the laser action or laser oscillation will start in a 4-level laser system. So what is the meaning of S21? S21 represents the spontaneous emission from level 2 to 1. So here spontaneous emission level 2 to 1, which is non-radiative, should be faster than A32. A32 means what? A32 here, this one T32, or this is your A32, because this is the radiative transition, also spontaneous. So spontaneous emission between 3 to 2, this one A32 is nothing but spontaneous emission from 3 to 2. So if spontaneous emission from 2 to 1 level is greater than that of probability of spontaneous emission level 3 to 2, then laser action or laser oscillation will start for a 4-level system. So this is the condition. So both are spontaneous emission. So only for that, in general, what we can write? We can write T21 should be greater than T32 if we expect laser action or laser oscillation for a 4-level system. Okay, so this is the derivation for your rate equation of 4-level laser system. Here we got the condition. What is the condition that we can get the laser oscillation or laser action in 4-level laser system? This question, if you will ask in your exam, it will ask for 3 to 5 marks. So you can omit the mathematical steps, but this much is enough for 4 to 5 mark. Okay. Okay, here I am going to stop this class. In our next class, we are going to discuss some important numerical based upon uh, Einstein coefficient and previous topics, whatever we have been discussed. Okay, thank you so much for watching this video. Thank you.